Okay, ладно. Why I do it? I'll switch to English because I do speak Russian, but I rarely use it for technical stuff, so I'll just use in English, which feels more natural to me. And I'm going to talk about the Swift Package Manager, and let's make it great finally. This is my topic of my talk. I'm from Norway. I work at a company called Xcode, which is a Norwegian company. You probably don't know about it, but maybe you know me. Like I jumped in Swift from day one. I'm the rebel or the crazy one. It was painful. I also wrote a book about Swift high performance. If you have any question about it, I love to talk about it as well. And I do contribute to Swift Package Manager. I think it's a really awesome project. So let's talk about dependency management in iOS these days. And we can sum it up in one thing, I think. Like pod install does everything. And it's kind of nice because like this is what all you need. You just pod install and you're happy. Until you need something more and you start digging it. Like what does pod does for you and how it works and how I can customize and how I can fix things and do things. And then it starts to be a magic, but it starts to be a black magic and painful magic, and it's kind of dirty inside. Like I'm not sure if some of you know it, but it's dangerous stuff there. And to really understand like what kind of stuff we need, like what kind of package manager or dependency manager tool we need, I want to go back a little bit and see like how was it before, how was our life before we get pod install, and it was painful. Like how the first thing, like for me back in somewhere 2000 something, I remember there was no CocoaPods, and who remember those time there was like no CocoaPods? Many? Yeah, there's some people. Cool. So imagine this stuff, like you go somewhere, you find a library, and it's static library.a. And you open it, and like just you have one header file, and it takes only IDs, no types, no documentation. And like, it's cool. Okay, I'll just pass an array. It crashed. I passed in a subject. Oh, it works. Oh my god, it was terrible. The second thing is like the copying code. Like some solution was just like copy code, put your project, and it works. Like you cannot have modified code if you find a bug. Like what you should do with it. Like it was really hard and painful. Like then I got sub-project and workspaces when you can link sub-projects like your dependencies, which CocoaPods kind of does these days, and it kind of solves some problems, but it still was like not perfect. Like if you need to find a bug or fix it, like what you do next, like you fix it, and like the versioning and everything was completely horrible. And yeah, this is the problems actually I described right now we faced before having CocoaPods. And one of the bad things that happened is still happening. Like imagine if you have there's a conflict resolution problem that if you have a project that depends, for example, in this example, you have an app that depends on A and B libraries, and they both depend on library C. What happened then? Before CocoaPods, you get duplicated symbol on compile time, and basically that's it. Like if you have static libraries, that's it. Like you can't do anything. You just can't use this library, and it's painful. If you use a workspace, like you imagine you have two projects that use another project and use just like drag and drop them into Xcode, you have to somehow figure out how to use the one of them, and there is no versioning. Like you cannot know like what kind of version this project uses and that. Like it could take days or weeks to try to fix it. So these days, it's kind of get simpler. Yes, show CocoaPods does the magic thing. So let's just look around more, like what's CocoaPods, what it does. it's a centralized dependency manager. It means that all the packages lives in one place. Like as for me, I think it's actually a bad thing. Why? If you remember, I think 3 months ago, there was a problem with the GitHub went down, and the actual problem was that everyone was trying to clone a CocoaPods repo with all the specs, and then everything just broke. Like you can't use CocoaPods if you cannot clone the repo. It was before. So still, like having one central truth of everything is kind of bad, because like if it's broke, then you fucked up. You can't use anything. CocoaPods use annotation of pod specs. It's just okay, but still, like when you have to publish your pod to update it, you have to update like 2 things. First, you have to update your code, and then you have to update your pod spec. So we have to consider it if it's a good thing or not to store, like for example, your project version in 2 places, or like what kind of things it has to link to. Like you have to declare, like I have to use this library directly in my code and also in pod spec, so it's duplicated thing. Like is it good stuff or not? And yeah, the good thing, it can make you a library and frameworks, which is actually really good stuff. But from a bad, like what CocoaPods does is that you say what you need, like you declare your dependencies, and it will fetch it and put into everything in one workspace. So it just creates a workspace for you, but it doesn't do anything like building or anything like source code analysis. It just makes a workspace for everything. And it works, because this is what we needed back in 2000, I'm not sure, 10, I think. But yeah, it works. It fits for our needs. So we use it. But then, when Swift came out, we got this another dependency manager tool called Carthage. And the real difference between Carthage and CocoaPods that CocoaPods, yeah, it's magic. You just do pod install and you get it. But inside it's really complex. It's easy to use it. It's just one line, but inside it's like really, really complex stuff going on. Carthage, in other case, it's still easy to use, but it's really simple. It does really, really simple stuff. If you go and see inside, it's just like one line, simple stuff. It's decentralized. It doesn't have one source of truth. There's like when you make your project, that's it. You don't have to do anything to publish it or share with your friends. There's no CocoaPod spec, nothing. It uses your Xcode project file. You make a project, it uses this stuff. And the really nice, I think, about Carthage that it relies on 2 tools. It doesn't do everything by its own. It relies on a Git to get a version, name, and all information about your package, like where is it, gets tags. And it uses Xcode build tool, like, or Xcode actually build the things. So the Carthage does only version resolution and fetching your packages, but it delivers all the heavy work to other tools, which make it more and more robust, because if something changes in Xcode, how it's built the projects, then it's automatically resolved in Carthage. But it only can make a frameworks. So result of a Carthage, it actually builds the things. It doesn't modify your workspace on anything. It fetches the project and builds it, delivers this to Xcode build, and it builds it and it gives you frameworks, which is nice, but still a bit complicated. Wrong, we'll see why. So, yeah, are we happy? Like, yeah, kind of, it works. But if we see, like, for example, when Swift came out, we wasn't happy at all. We had only CocoaPods, and the CocoaPods worked only with static libraries. And Swift said, we don't support static libraries, we just go for frameworks. And we said, oops, what should we do now? Like, okay, we went back to using like manual stuff, submodules. It was painful, and that's why Carthage was created. So we're kind of happy, but if you go and see deep inside, it breaks every single time. So we're kind of like the CocoaPods developers are really not happy. I can say it for sure. So yeah, what kind of problems? It relies on the private APIs. It's really, really bad things to rely on the Xcode project stuff, like the framework, format, or anything. It breaks every single time, and WWDC, so tons of issues. It's not integrated with tools made by Apple, and it's really hard to do something if you don't have a proper integration with APIs. And like, yeah, let's fix everything about custom script. Like you see all those things, like if it doesn't work, let's just put one more custom build script. And I think it's really bad solution. Like if you just, we have some backdoor stuff. Like we had, for example, with Xcode plugins, like, oh, we can just use private APIs and everything fine. And then Apple say, nope, we just remove it. And what we do then? Like we should be prepared for this stuff. Like if you use custom scripts to do some tricks, probably it's a bad solution. We should get a better one. And so yeah, that's why we need Swift Package Manager to do this stuff, like properly. And yeah, we'll do it. So the first question, like, why was Swift created? I would like to say, like, yeah, Swift Package Manager was created to solve the issues on iOS, but the truth is, like, it's not actually. It was created by another guy, Linux, or when Swift was going open source, and like when they added support on Linux on the servers, there's no way to build your packages or application on Linux and like make dependencies on Linux. There's nothing works. So that's why actually Apple invented this tool to make the Swift on server life easier, and they're actually using it in production. It's only tool available. It works for them very fine. But yeah, it's not made for iOS directly. It's not the intention, because we have tools to make it work on iOS, but it's coming there. So we will use Swift Package Manager on iOS like in some years. So what is Swift Package Manager? Like, what is it? And so from Swift.org, you can say it's a tool to download, build, link, and test your packages. And the three keys to its architectures, it's cross-platform, so it does a lot of impact on the architecture, how they make a Swift Package Manager. It's cross-platform. It has to run on all the platforms almost on all that Swift can run as well. It uses so there's no like things like Xcode. You have to think, how can you make things work without an Xcode? It's decentralized and use conventional approach, which says like we'll do these things this way and not use like some crazy configurations like a lot like an Xcode. And Swift Package Manager actually consists of three things, like three tools. It's Swift package, Swift build, and Swift test. So the Swift Package Manager can like fetch your dependencies and do a lot of different things. It can build your dependencies, or actually not dependencies, but a package. And it can also run the tests. And the cool thing is that all the underlying tools, like for building, they're open source, and for testing as well. So if we need something else like for testing or like for building, we can go and contribute there when people are doing it. So like we have full control over our tooling stack. And the Swift package does really cool things, like an overview of what you can fetch packages, you can generate Xcode projects, you can dump some internal data, so you can get like a JSON integrate further in different servers or like tooling. Like I can do like visual analysis of dependencies tree. It's really cool stuff there. But you're not here. So the thing is like, what is a package? Swift Package Manager works on the packages, and like if you think about it, like CocoaPods and Carthage, they use word dependency, but Swift Package Manager goes on a bit different way. It uses packages, and the package can be kind of like everything. It's your dependencies called package, but also your app can be a package. So you can use Swift Package Manager to work like on your whole app and build it for you. And so it sounds complex, but in reality it's really simple. Swift like package is something that has a manifest file which In 4 lines, it's import package description. It's Swift format, by the way. And it just describes your package. It says your name. And that's the minimal stuff that you have to do to make like your project a package or your library a package. This way, Swift Package Manager can understand that if this file is in your root, like you have in your folder, this is a Swift package. I can build it, I can use it, like it has this name. Okay. The next thing, like we want to do stuff. We want to write code. Right now, it supports 4 languages. No, actually 5. You can write in Swift, C, C++, Objective-C, and Objective-C++. So this is the languages we can use to write in our packages. The one small limitation, which you think is like, wow, it's cool, like all the languages, but it's 1 language per module, and module is like your target. Like if you think about iOS, it's, yeah, if you work with Clang, it's a Clang modules. But yeah, it's kind of like a thing that you make after build. So you cannot mix all the languages like what we do in iOS. You just make small package modules and with different languages and build them together. It works seamlessly and nice. And we can produce, like the input, we use those languages, and we can produce different stuff. Oh, I think I have not so many time. Yeah, we can make libraries static and dynamic. We can make executable tools, but not the apps. And we can do system modules. So let's quickly see how it looks like. The convention approach that I mentioned is that there is no Xcode project. There's nothing. Like you saw, there's only a name. So how does the Swift Package Manager understands like how to build our projects? Like where's the source code and everything? It follows the convention approach. So we use special rules. Like all the sources has to be in source folder, test in test. If you put a main.swift, it will be executable, which makes sense. Like if you put something else, it will believe. For C, you have to put your headers in include folder. So this is basically rules you have to follow. And it kind of worked nice, but yeah, it's like huge projects still need different rules. There's discussion, so maybe we'll see something different. But this makes life really easy to make your packages if you follow those rules. And there is no way that you don't follow your rules, those rules. It will just not work. So here's a few examples. Executable, simple stuff. Package.swift, main.swift and source. You run Swift build, you get executable. For lib, you get put a lib. If you want to two modules, you put a subfolder in a source. And yeah, you get the stuff. Oh, yeah. You put 2 folders, you get 2 libraries. And there's system modules. The nice name, and what is it? If you think about system module is, what if you have a tool installed on your machine, which makes sense for server, not for iOS, and you want to use it. This is Clang modules, and CocoaPods actually also use it as well. So you basically say, okay, this is a tool, it's located here with this name, export it, and then you can use it as regular Swift, like regular module in Swift Package Manager. There's no difference. So this makes really awesome to use stuff installed on your PC. Using like how can it be used in iOS? Like some core data generators, fast lane tools, everything angle tools that actually installed. Like you can use it here. It would work pretty nice on iOS as well someday, definitely. So you did it. Like now we want to ship the stuff. Like you wrote your code, put it into source folder. You did everything. Like how can you? What's the next point? So Swift Package Manager uses a Git as similar to Carthage. So you make your Git commit, adds a tag, and yeah, you ship it. That's it. It uses just a Git, and there is no step 2. It's that easy. Like if you want to use your package, you just say like in your description, package.swift manifest file, you say dependencies, put your link where it's like git link, git URL, and you specify the version which should use. And this follow semantic versioning. So I encourage everyone like use semantic versioning as much as possible, definitely. There's different rules how you can specify dependencies. Like you can use, you can use really different, like just a string. You can use a local. You don't have to push it to remote repository. You can use like local packages, just like, okay, this package is in this directory, and yeah, there's different APIs for version, and this is all Swift code. It's Swift, use Swift for describe itself. There is no Xcode project, right? But there's a lot of power we describe in manifest file. We have name and dependencies, but also we can describe like what kind of targets, exclude, and different stuff. I'll quickly show it if, still have time. So what say if you have like 3 targets? Like we have source and then we put like core login on network. But the problem is that we want to have there is no dependencies specified here. Like we want to login to be dependent on network and core. We can use it, like how can we do it? And we can do it with targets. We can say like, we have a target login that depends on core network. And now Swift Package Manager will build all of those and link together. So linker knows how to do this stuff. Exclude, simple, like you want some stuff to be excluded. You want to say like to Swift Package Manager, don't build stuff here. This is just, like images or like some mock JSON. So you can exclude stuff, simple. The pkg-config, I really like. It's like, let's say you have some library you installed, and to use it, when you build it, you have to specify like where to find it. And you would pass this compiler and linker flags every single time. This is what is happening behind the scene in iOS. Like if you open the build log, we actually pass in the things. And to make it simpler, like pkg-config, it's a standard tool and convention, which has been with us for many years, but we haven't used it actually in iOS. But you can just say like when you install some package, some tool with Brew or MacPort, or just install it in different ways. They almost always came with this pkg-config file, so you can just say like use this pkg-config file, and then I don't need to specify anything. And if you go inside, this is just some file predicated on your machine with default location, which describes what to do and what to pass the flags. So we reduce the complexity of the build tool a lot by this. But if there's not such tool, right, there's like always, you open the README, you start to read like how to set up your project, or you have like a make file which says, install the CocoaPods, if CocoaPods not installed, do this, do that, like install this and that. Like what's if the tool is not there? The solution is really simple. When you create a package like this, you can provide how can you install it, and Swift Package Manager will try to use it. Like if there's not a GitLab tool, it would say, okay, I will go, if I'm on a Mac, I'll notify you. It will not install it, but it will give you instructions to user, like how to install. So we don't need to have like custom README file saying like, oh, do this and that. Like it's all handled by Swift Package Manager now. And there's like a lot of more stuff. I said you can make dynamic and static libraries. Then there is coming evolution proposal to add to products. So basically, just describe like it's a library with static or dynamic. So we can actually make, I think we can make a static Swift in Swift Package Manager. But only for on the Mac. And there is a lot more cool stuff coming soon. It has an Xcode integration, or proper Xcode integration. If you run Swift package generate Xcode project, it will take like the package or like the things you have and generate Xcode project for you. You don't include into your repo. You don't want to commit usually your Xcode project. It usually goes to git ignore. But you will do it like to have proper ID if you want to go and, for example, run test and do the things. You have an Xcode project. And another cool thing that you can actually use, like the Xcode has a lot of configuration baked in, and you can pass, like all the settings can be set up in an xcode-config file, and you can pass it to Swift Package Manager to use it. So we kind of have a power of Xcode without an Xcode. We can use just Xcode-config files. So yeah, is this really kind of can be used on a production? Does it scale? Does it will work, handle my scale, right? And actually it does. The Swift Package Manager uses Swift Package Manager to build Swift Package Manager, kind of Swift-ception. It's true. The Swift Package Manager itself is huge. Like it has 90 modules, 21 targets, like a lot of code. It's a huge thing, and it's like you can just go and say Swift build. You clone the repo, Swift Package Manager. The first you have to somehow, like yeah, if you have Xcode 3 or Swift 3 and Xcode 8, so it comes with Swift Package Manager already. You have to just clone the repo, Swift Package Manager, and make Swift build there, and it will build itself, which is really cool. And yeah, this is the scale. It's huge, and it works really amazingly. So yeah, it should work. Like yeah, maybe not for Facebook yet, but it works for itself. So it really does handle a huge scale. The iOS state of art, it's I kind of put a sad face. The reality, you can make it work, and there are a lot of people doing it, but because Swift Package Manager changes like so often, like the solution that worked the week before, it doesn't work probably this week already. Yeah, because it's changing a lot. So the Apple team is not investing so much effort in support iOS, and there's not official support yet because you have to link for different frameworks. You have we have info playlists. We have like a lot of configuration for iOS, how they link and build things. And yeah, the plan is that the Apple said and Swift team said they will do the iOS integration, but in the future, because right now you can build Swift apps like iOS. You can make iOS apps and works fine, but there's nothing for server. So we solving the real problem right now, and we add iOS support later. Yeah, but they will not probably like what they said. It's really interesting that there will be another tool to actually do building for iOS, so it will not be an Xcode, which is really interesting, but it's like nothing. There's no more information. It's kind of like I heard something there and there, like, so it's really looking forward to it. So like, it's really Swift Package Manager is the thing. Does it really solve our problems? Yeah, kind of, like it's not our problems, like not for us, but eventually it will solve a lot. So the painless config, there's no like Xcode, like everyone's blaming the Xcode, right? The Xcode is like a bad guy, and we could just remove it. Like, there's no Xcode, we're just building without it. We have full control over like the building, and the cool stuff, like we also not only building, like we fetch the packages. Before we fetch, we can get all the information. Does your packages can it build? Does it have tests? Like we can do all these checks. Like we have full control over fetching packages, building them, running tests, getting all the informations, and it's like baked into everything, like into one thing. It's open sourced, and yeah, there's a lot of things like coming. If you're really interested, I encourage going to Swift mailing list and like ask questions. Like my one was the most interesting is like what happened if, like in CocoaPods, you still have this problem. If you have two packages and they depend, let's say you have some core data persistence thingy, and then you have something different thingy, and they depend on a different version of JSON library, the same library. Like I want JSON library 0.10 and I want 0.2. The CocoaPods will just break, say like I can't resolve this dependency graph. Like there's no way. And I asked this question on this mailing list. I say like, yeah, the kind of we can solve it. Like if you, because the Swift has the namespaces, and like if we change the language a bit, we can make the package to fetch different versions and make it work in future. If we change the language a bit, which Apple team can do, like and we can do as well. Like it's all open. So yeah, I'm looking forward to have this. Like it's really would be really awesome things to have. Yes. So now we have new magic Swift build, and it does a lot of things. Like if you open a project and you run Swift build, it will check your dependencies. So it goes to your Swift package file. It's like analyzes it, reads it, check if it's correct. It see if you need any dependencies. It fetches them. If it needs to fetch, like if it fetched already, like it wouldn't do it like again. Then it would just build those dependencies, link them together, like what target depends on what, integrate into your app, which is also a package, and build your package, which is app, and then you're happy. And the cool thing is about like I had lots of problem, for example, with Carthage, that if you shipped, you can build your frameworks and like cache them to save your build time. But then like you have to use the same Xcode and make sure. The Swift build kind of does the same. It builds things and cache them. So if you change like one line or just one dependency needs to be updated, it can update like small thing and have like everything pre-built, like have a cache. And it can analyze, like it has like more control over caching. Like is this the same Swift code? Yes, like Swift version, I can use the cache thing. If something has changed, I can rebuild it. So we have way more control. And we have full control over tests. Like if you want to, for example, on Swift build or on a Swift, I know, like push, maybe we'll have in the future, we can say like, oh, we have to run the test and make sure that all the test passes, which is also very powerful. Yes, so this is a new magic. Yeah, basically that's it. If you want to demo project, go to Swift GitHub /Apple/Swift Package Manager. Yeah, download it and play around. And yeah, that's basically it. If you have any questions, I would be glad to answer them.